Now a quick review on the quotient rule. Think of this as your high, this is your low. The derivative of high over low is equal to, on the bottom in the denominator, it's going to be low square. On top is low d high minus high d low. Okay. In terms of the function f and g, so on the bottom will be g squared. On top will be g times f prime minus f prime times g. Now let's apply the quotient rule to the number 4 here. So in number 4 we have a ratio, and we do see that if you call this as your high, this is your low. So the derivative, and let's say this is the function f of x. So now f prime will be the low square, which is x cubed plus 6 squared. On top will be low d high, low is x cubed plus 6, times the derivative of the high. So the derivative of the top, which is 2x plus 1 minus 0, right? And then the bottom one is going to be, the second part is going to be high d low. So it's x squared plus x minus 2 times the derivative of the low, which is 3x squared plus 0. Because for now, at this point in time, my focus is to make sure that you are able to apply the rule. That's my focus. So I'm not really looking for the simplification, which is really just a bit time consuming. So for now, I'll say I just look for this. So stop right here. Don't worry about simplifying too much at this point. So that's how I would apply the quotient rule for this particular problem. Let's look at the next one. So the next one, again, oftentimes there are a couple different ways to do a problem. You could certainly use quotient rule, because there's a low, there's a high. You can use low square on the bottom and then low d high minus high d low on top, right? So you can do that. I'll leave that as some exercise for you, but I would like to suggest you, whenever you see a single term on the bottom, that's a really nice form, single term, okay? Why? Because it can be, in other words, this rational function can be split into different terms. For instance, this is my first term, right? This is my second term, and this is my third term, which is reduced to this problem. And this problem is much easier to find the derivative than the problem that we had originally. Originally, you have a fraction. Now we only have 3 single terms. And to find the derivative of the very last one, think of this as 2 times x raised to power 1, to use the power rule. So now I'm going to find the derivative. So let's call this as f. So therefore my f prime will be equal to, instead of using the quotient rule, I'm using the power rule. Derivative of x, which is 1, plus the derivative of 1 is 0. So, and then minus 2 times the derivative of, so I don't use quotient rule, I prefer to use my power rule. So 2 times the derivative of x to the negative 1, which means move the power to the front, and then subtract 1 to the power, right? So eventually this is what you have, because it's x to the negative 2, so that means 1 over x squared. Okay, so that's that one. Let's look at the next one. For the next problem, because the denominator is not a single term like this is, So I cannot really, and by the way, the top is just a single term. There's no point of thinking about splitting. It will be wrong to split it like that, okay? That's not acceptable. That's not right. I usually call this as abusing the mathematical rule. Okay, no shortcuts. Just say, suppose this is your f of x. So to find f prime, the new denominator, you have low square. And then in the numerator, it will be low d high, right? Low times the d high, which is itself, minus high d low times the derivative of the low, which is 2x. And this time you see that e to the x this is easier to simplify, so I'm going to just pull the e to the x out. So I have x squared plus 1. And the next one is actually minus 2x. I'm left with minus 2x divided by x squared plus 1 and then square. And this guy actually turns out to be x minus 1 squared. Okay, so this is it for this one. And let's look at the very last one. Okay, very last one. Again, two methods. If you use your quotient rule, you're going to have this. So this is the quotient rule. The derivative of that is low square, low d high. So low times the derivative of high, which is derivative of 3 is 0, minus high d low, 3 times the derivative of x to the 9th, which is 9x to the power 8. And this is 0. And this gives me 27x to the 8th. The bottom I have x to the 2 times 9 is 18. And after the cancellation, you have x to the 10 on the bottom. So this is using quotient rule. Certainly, you can rewrite this as 3 times x to the negative 9. And then you use your power rule instead of quotient rule, right? So it will be 3 times negative 9, move the power to the front, and then subtract 1 to the power. So you have negative 27x to the negative 10. Of course, x to the negative 10 just means x to the 10 on the bottom. So this is it for showing you how to apply quotient rule in these several problems. Those are the only two rules that we learn in this section. A new rule is for the derivative of e to the kx. So this time there's a constant k here. So how do we compute the derivative of this e to the kx? Simply just extra k in the front. Okay. So why is this? This can be proved using a so-called mathematical induction, or can be proved in the future, can be proved using chain rule, so-called chain rule. But you can certainly look at a few examples, like for instance, e to the 2x is the same as e to the x times e to the x, right? So when you find the derivative of this guy, you are finding the derivative of this guy. And then how do you find the derivative of ex times ex? According to the product rule, is the derivative of the first function, which is itself, times the derivative times the second one, plus the first function times the derivative of the second one, which is itself as well. So I'm applying product rule. And then you can see that they are the same, which is twice 2 of the e to the 2x, right? So that's kind of showing you how this works. This can be proved using product rule. So now let's look at the first one. We already know that this k is equal to 2. So the derivative of this guy will be 2 times e to the 2x. And the second one, the k is negative 3. This is the k. So when you find the derivative of this guy, you're going to have negative sign. This is still negative sign here, times k, which is negative 3, e to the kx, which is negative 3k. I'm sorry, negative 3x. So this gives you 3 times e to the negative 3x. All right, so those are the rules that we learned. And now I will make a separate video for the rest of the problems.